Welcome, everyone. Today we're diving into the world of digital twins.
Yeah.
They're not just some techie buzzword.
No.
They're changing how we think about designing, building, managing, everything really, from cities and bridges to
Pretty much.
farms even.
Farms, you name it. And actually, the whole concept might be more familiar than you think.
Really?
Yeah, remember the Apollo 13 mission?
Oh, sure.
When that spacecraft ran into all that trouble?
Right.
NASA? They essentially used an early version of digital twin thinking to solve the problems,
Wow.
to bring those astronauts home.
So it's like having a virtual version you can experiment on without
Yeah, a stand-in. You can poke at it, prod it, experiment with it.
without the risk.
Exactly, without messing with the real thing.
And I guess that idea has been evolving over time.
Absolutely. So in the 80s and 90s, we started to see more sophisticated digital models.
Like what?
Well, take satellites, for instance.
Okay.
Engineers were building these really detailed virtual replicas.
Oh, wow.
And then they could get live data from the actual satellite up in space.
Through telemetry.
Exactly. It was like a real-time view of how it was performing way up there.
That's incredible. Like a virtual dashboard for something super complex.
Yeah, you got it. And actually, it was Michael Greaves who coined the term digital twin back in 2002.
Okay.
But the real, I guess, explosion in this field came recently with,
With all the advancements in AI and...
AI, Internet of Things, high-speed communication,
Yeah.
all of that coming together.
So we can build these complex digital twins that actually learn.
Exactly. They can learn and evolve in real time, making them even more powerful.
So they're not just mirroring reality anymore.
Not anymore.
They're participating in it.
Absolutely, they're active participants. And that's what really sets them apart from just any old simulation.
Okay.
A true digital twin has this constant two-way flow of data with its physical twin.
Right.
We call that live digital coupling.
Live digital coupling.
Yeah, it's like a conversation happening between the real world and the virtual one.
So it's not just a snapshot. It's a relationship.
Exactly. A dynamic, constantly evolving relationship. And because of that, you can do so much more with a digital twin.
More than what?
You can run what-if scenarios, test different conditions, optimize performance.
Right.
You can even anticipate problems before they happen in the real world.
Oh, wow. Okay.
The applications are pretty mind-blowing, going way beyond just rockets and satellites.
You've definitely got my attention, so tell me more about these applications.
Well, imagine cities using digital twins to plan for growth, manage traffic flow, even optimize energy use.
Mm-hmm.
Or healthcare using them for personalized treatment plans,
Right.
And even virtual surgery simulations.
Oh, wow.
Or even seeing them used in infrastructure projects
Oh, yeah?
to design safer bridges and manage these complex railway systems.
It seems like there's no limit to where this can be applied.
It's pretty broad.
Is there a way to categorize all these different types?
Yeah, there are some ways to think about it. On the simpler side, there's what we call plain gadget models.
Plain gadget models.
Yeah, they're basic, maybe showing you sensor values and expected performance.
Okay.
Then you have the more, let's say, sophisticated ones,
Okay.
the embedded digital twins.
Embedded digital twins.
These are really actively involved, running simulations, informing decisions, even controlling processes in real time.
Wow.
Yeah. So you've got the simple ones and then the ones that are really getting in there and doing the work.
That's amazing.
It is.
But where are we, realistically? Like, this all sounds so futuristic.
Well, it is a rapidly evolving field. There's a lot of buzz. But how much true machine learning is in commercial digital twin software?
It's kind of a mystery.
A little bit, yeah.
So it's more digital twin ready than true AI-powered twins.
Yeah, that's a good way to put it.
But are there things on the horizon that make you think, okay, this is really good?
Oh, absolutely. There are some very promising techniques coming up, like continual learning. This could let a digital twin constantly learn from new data and become more accurate over time.
So it gets smarter with experience.
Exactly, a digital twin that gets smarter with experience. But, of course, there are challenges.
Like what?
Well, figuring out how to prevent the model from forgetting old information as it learns new things,
Right.
It's like teaching an old dog new tricks without making him forget the old ones.
And I think you mentioned another technique earlier.
Federated learning, this one's a game changer.
How so?
Imagine digital twins from different companies or even different countries learning from each other's data,
Wow.
but without actually sharing it directly.
So like a global network of digital twins.
Yeah, all learning and improving together.
But what's holding us back? from this, digital twin utopia?
Well, there are hurdles. Security is a big one.
Yeah.
Protecting the data flow between the real and virtual world is critical.
Makes sense.
Then there's the question of how do we know how well a digital twin is doing?
Right. How do you grade it?
Exactly. Especially across different industries, different applications, it's not a one-size-fits-all situation.
And what about just managing all the data?
Oh, data management is definitely a challenge.
Yeah.
We're talking huge amounts of data, especially for complex systems.
So what do we do about that?
Well, technologies like hybrid cloud and augmented data management are becoming so important.
So we don't drown in a sea of data.
Right, exactly.
Anything else? Anything else that we should be thinking about?
Yeah, another really crucial concept is the digital thread.
What's that?
This is basically a continuous stream of data that follows a product throughout its entire life cycle,
Okay.
from design and manufacturing all the way to operation and even disposal.
Like a digital biography?
Exactly. And this is where the power of digital twins really shines.
How so?
Well, by integrating the digital twin with the digital thread, you get a much more complete picture.
Okay.
This enables better decisions,
Right.
process optimization, valuable insights at every stage.
Okay. I'm starting to see the big picture now.
Good.
But can you give me like a real world example? Something that brings all this to life?
Sure. Let's talk about Edelfer, an Italian engineering company.
Okay.
They're using digital twins for infrastructure projects. They used a method called BIM, which incorporates digital twin principles, to create a virtual replica of a viaduct they were building.
A viaduct?
Yeah, like a bridge.
Oh, so they basically had a digital twin of the bridge.
Before they even started building it.
Wow.
Right.
That's amazing.
Yeah, it allowed them to do some remarkable things.
Like what?
They were able to identify design clashes early on.
Which saves money.
Yeah, a lot of time and money.
Right.
They used a software platform called ProjectWise as a central hub for all the project data.
Cool.
This made collaboration much smoother, and they used 3D modeling software to create this detailed virtual model of the entire infrastructure. They even used laser scans of the terrain to make sure everything was super accurate.
It's like they built the bridge virtually before they built it in the real world.
They really did.
That's really impressive.
It is.
But before we go any further,
Yeah.
I just want to make sure we're all on the same page.
Okay.
How is a digital twin different from just, any other simulation software?
That's a great question, and it highlights a key difference.
Okay.
Digital twins, they're not static simulations. They're dynamic, interconnected, constantly evolving.
Right.
Remember that live digital coupling we talked about?
Yes.
That's what makes a difference. It's that ongoing two-way data exchange between the physical and virtual.
So it's not just a one-time simulation.
No, it's an ongoing relationship.
That back and forth.
That's what allows the digital twin to learn, adapt, and provide real-time insights
Okay.
that you wouldn't get from a traditional simulation.
I think I'm starting to get it.
Good.
It's all about that constant communication.
Yes, that's key.
But what does it all mean for the average person? Like, why should I care about digital twins?
Because digital twins are about more than just cool technology.
Right.
They're about unlocking potential. They can lead to better decisions, streamlined processes, reduced risks.
I like those.
Right.
Yeah.
And ultimately, they can open up entirely new possibilities.
Okay, I'm on board.
Great.
I'm officially on the digital twin train.
Excellent. So now let's explore some more specific examples that really highlight the power and versatility of digital twins.
Okay, great.
Let's dive in. Think about this. What if digital twins could not only mirror their physical counterparts, but also interact and learn from each other?
That's a fascinating thought. You mean like those,
Those social assets, exactly.
Yeah.
It's a pretty new concept, but it has a lot of potential.
So it's like digital twins getting social.
You got it. Imagine a network of digital twins, each representing a real-world thing, like a machine in a factory. Or
a car.
a car, yeah.
On the highway.
Exactly. And these
Yeah.
digital twins, instead of working on their own,
Right.
they're all connected.
They can talk to each other.
They can communicate, yeah.
So they're forming their own little digital society.
In a way, yes. They can share data, insights.
But how does that help us in the real world?
Okay, let's say you have a factory floor full of machines.
Okay.
Each one has its own embedded digital twin.
Right.
Traditionally, those machines, they operate independently.
Yeah.
But with this idea of social assets, they can form a network.
They're all connected.
Connected, exchanging data.
Instead of working in silos.
Exactly. They're collaborating, learning from each other's experiences.
So they can be like, hey, I'm having this issue. Has you ever seen this?
Right. They can communicate about performance, workload, potential problems.
To make the whole factory run better.
Yes.
Yeah.
Fine-tune production, schedule maintenance,
Wow.
adapt to changes, all much more efficiently.
So it's like a team of smart machines all working together to figure things out.
That's a great way to put it.
I like that.
Yeah.
Where else could this social aspect of digital twins come in?
Oh, think about electric vehicles.
Okay. Imagine a network of charging stations, each with its own digital twin. Now connect all those twins.
And you've got a smart charging system.
Exactly. It can manage charging demands.
So you don't overload the grid.
Right. Optimize energy use, even predict potential overloads.
Wow, that's really cool.
Each charging station's digital twin can share information.
About what?
Capacity, types of vehicles, local energy availability.
So the system knows where to send cars to charge.
Yes, intelligent routing, balancing the load.
Really smart.
It's all about that communication.
But with all this sharing, doesn't that raise security concerns?
Absolutely. Protecting that data is critical.
Right, because you don't want to compromise anyone's privacy.
Exactly. So
Okay.
as this technology keeps evolving, we need strong security.
Encryption, things like that.
Yeah. Robust protocols and encryption
Yep.
methods.
It's like a digital neighborhood watch, sharing information, but keeping things secure.
I like that analogy.
So we've talked about social assets in manufacturing, transportation.
Right. Where else might we see this?
How about a smart city?
Okay.
Buildings, traffic lights, the power grid, even public transportation.
All with their own digital twins
Yeah, all interconnected.
and working together to make the city better.
Exactly. Optimizing traffic flow, managing energy, enhancing safety.
Wow. A truly smart city.
That's
Well, we've covered a lot of ground on these digital twins.
we have
From their history to these social assets.
a lot to think about.
It's been really insightful.
Yeah, and we've only scratched the surface. This field is constantly evolving.
It's amazing to think where it might go.
It really is.
So now, let's look at some emerging trends, some future possibilities for digital twins.
All right, let's do it.
It feels like we're really on the edge of something big,
Yeah.
like a digital revolution.
A revolution.
And these digital twins are leading the charge.
Leading the way.
So what trends should we be watching? What's coming next?
Well, the way digital twins are merging with other technologies, that's definitely something to keep an eye on.
Okay.
We talked about AI and machine learning,
Right.
but blockchain could also be huge, especially for those social asset networks we discussed.
Oh, yeah, because it adds a layer of security.
Exactly, like a digital trust system
Right.
where each twin can verify the information it's getting.
Makes sense.
Any other technological advancements you're thinking about?
Well, I mean, sensors, right? They're getting better all the time.
Oh yeah, sensing technology, data analytics, high-performance computing,
All playing a role.
all contributing to making these twins more powerful.
So we're talking about sensors that can gather even more detail.
More data, deeper insights.
And the computing power to handle it all.
Exactly.
It's like giving digital twins super senses.
Chance says
A
yes.
super brain.
A supercharged brain.
And the muscle to do even more.
It's incredible.
So imagine digital twins that can predict failures before they happen,
Precisely.
optimize performance in real time,
On the fly.
even fix themselves.
Self-repair, absolutely.
It's like those self-driving cars, but for everything.
It is. It really is. It's pretty remarkable when you think about it.
But what about us? What about the human element?
Right, that's a key question.
How will digital twins change how we work with technology?
Well, I think the human-machine interface is going to change drastically.
Okay.
We're already seeing VR and AR being used with digital twins.
So you can actually step inside the digital twin.
Yeah, more intuitive, more immersive.
Wow.
And as things advance, imagine controlling complex systems with just your voice or hand gestures.
That sounds like science fiction.
It's getting closer all the time.
But surely there are still challenges, right?
Of course, interoperability is a big one.
Meaning what?
Well, right now, everyone's building their own digital twin platforms.
Like their own standards.
Yeah, so it's hard to share data, connect systems seamlessly.
So it's like everyone's speaking a different language.
Exactly. We need common standards, common protocols.
Like a universal digital twin language.
That would make things a lot easier.
And we've talked about ethics,
Right.
but there are other things to think about, right? As this technology becomes more integrated into our lives,
Definitely privacy, intellectual property, making sure these twins are used for good.